Try this problem. Afterwards, I'll cover the key concepts, and then we'll work out the problem. Alright, this is a multiplying vectors problem. Let's remember that vectors have both magnitude and direction. And we have two main ways to multiply vectors. One is the dot product, and the other is the cross product. And in this problem, we'll take a closer look at using the cross product. When we cross two vectors, the cross product gives us a vector that is perpendicular to both the original vectors. So say we have a vector going along the x-axis and then another vector going along the y-axis, and these would be perpendicular to each other. The cross product of those two vectors will give us a resulting vector that is perpendicular to both the original two vectors. So moving on to the problem, I can see that vectors A plus B plus C take us back to the original location. So the sum of these vectors is 0. Another thing to notice is that vectors A and B are perpendicular. That'll be important. Okay, part A is asking to find the magnitude and the direction of A cross B. So we can write that as the magnitude of A cross B is equal to the magnitude of A, in this case it's 4, times the magnitude of B, which is 3. So the answer for part A is 12. Now we can do this because vectors A and B are perpendicular to each other. So one equation you want to remember is, again, the resulting vector's magnitude, C, is equal to the magnitude of A and B sine theta, theta being the angle between A and B. So sine 90 degrees is 1. So you can see that the magnitude of vector A times the magnitude of vector B will simply give us the magnitude of vector C. A times B will give us C. Alright, so part B is now asking us for the direction of A cross B. Remember, unlike the dot product, where it's commutative, the order does matter when you're taking the cross product. In other words, A cross B is not the same as B cross A. Okay, let's rewrite vector A in unit vector notation. For I, and we're going to cross that with vector B, which we can rewrite as 3j. And since they're both one-dimensional vectors, that's those are the only components they have. So again, we have 12, and I cross j will give us k. So the answer to part B is the resulting vector is going to face the positive z direction. Now, you can use the right-hand rule to figure that out, the direction of the resulting vector, or you can also write the vectors I, j, and k in this circular manner. And if you cross clockwise, which we're asked to do here, I cross j, your resulting vector will face the positive, will be positive k. In contrast, if you were to cross counterclockwise, j cross I, then the resulting vector would have been negative k. Alright, next let's work on part C and D, which is asking us for the magnitude and direction of A cross C. So A cross C can be rewritten as vector A cross the components of vector C, which is negative A plus negative B, which is negative B, and that's because C is going in the opposite direction. Sorry, magnitude. And that'll give us negative A cross B. Which will give us 12. So we can rewrite this in unit vector notation as A is, what did we say, 4i cross the components of vector C is negative 4i minus 3j. Alright, so if we cross I and I, they're parallel vectors, so the angle between them is 0. So recall C equals AB sine theta. When theta is 0, sine 0, this whole term is 0, so that's going to end up just being 0. So you can write 0i, and then 4i cross negative 3j is going to be negative 12, and I cross j is k, and so that's going to be facing in the negative z direction. Alright, so in our last two parts, we're taking a look at the magnitude and direction of B cross C. Alright, so the magnitude of B cross C, we can rewrite that as B cross the components of C, which we said earlier was negative A plus negative B. And so that will give us the magnitude of negative B cross A, which is 12. Alright, so let's take a look at that in unit vector notation. Vector B, we're going to rewrite as 3j, and we're going to cross that with vector C, which is negative 4i plus negative 3j. Alright, so if you, this here term is going to be negative 12. J cross I is negative k, so our resulting vector is going to be facing positive z because the negatives cancel out, the two negatives. Alright, and again, J cross J is, they're parallel, so that part is going to be 0.